Hey everyone. Now that we've upgraded everything to 0.3 and I have that code up on GitHub, I thought now is a real good time to go over a recap of what we've done thus far, probably what we'll do in the next couple of episodes. So, first episode that we have, and I'll put all the links to these videos in the show notes below, we learned that with very little code, we were able to come up with a custom scenario to start training in Unity ML agents, and that yes, we can actually get it to work, and that this was actually a really good way to test to make sure that we had all of our configuration correct. This turned out to be really helpful when we started to do some work with upgrading things, because then I had a very simple scenario that once I was able to get this work, I knew the kinds of changes that I'd have to make in my later projects. So this was very valuable. The next project we went into was training multiple items at the same time. So instead of just training one instance of the problem, we are able to train 20 instances of the problem, and this resulted in a fairly large speed up for what we were doing. And we knew that was the result that we really expected, so there wasn't too much that was groundbreaking in that, but it's still a good exercise to go out and get into those prefabs and also learn how to wire up the prefabs to the brains at runtime, because that could also be useful. Episode 3, we got into gravity and how do you properly integrate the physics engine of Unity with the ML agent. So while the behavior of this looks a whole lot like the behavior of the second scenario, the actual actions that are being taken behind it are very different, because now gravity is pulling all of the markers down and the system is constantly trying to keep the markers on their targets. Now, episode 4 is where we started getting a little experimental. This is another advantage of having a simple system, is that you can run experiments with it to try to understand it better. So in this one, we moved from a discrete reward system to a continuous reward system. And this resulted in faster training, so we were starting to get longer and longer training times, but by moving to a continuous reward system, we are able to more quickly converge our training. And in many cases, depending on how you author it, you can also eliminate some of the shakiness and vibration that can come in some of the results. In this case, we haven't done that, but it's absolutely plausible for a continuous reward system to help remove some of that in-state vibration that you'll see in a number of scenarios. And then finally, with the fifth one, we're starting to add more game elements. We're trying to make the project more and more complex, like you'd actually see in a real game. And so this is where now we have an obstacle at the bottom where the markers have to gently approach it and stop. And so you can see in this case, we're not getting any of that vibration. We're getting maximum reward, and that everybody is landing very, very cleanly. Every now and then we'll have one crash just like that, and it'll restart. But for the most part, everything happens very smoothly, and it does an excellent job, far better than any human player would ever be able to do. So those are the 5 episodes that we've done at this point. From here, where we're going, we are going to be doing... we're going to be going from a one-dimensional problem to a two-dimensional problem. So in this case, we're taking this up to the lunar lander problem, as was suggested by one of the viewers, and then we're going to kind of pause and reassess there. But so to get to that lunar lander, we need 2 thrusters instead of 1. That way we can turn left, turn right, and land. So that's going to be probably the next big upgrade. And then after that, we also want to get into fuel and then also some terrain randomization, so that, as it's learning the lunar lander problem, that it's getting some variations on the terrain. From there, we might take a quick pause and we work on some graphics, and so we can say, all right, now that we have these things behaving the way that we want, how can we make it look good? We're getting all of this information about what it's doing. Are there things that we can be doing to really up the visual fidelity and make this look real interesting to people who are watching it? And then from there, we can try some other examples. My original example was going to be a kind of a drone type movement in 3D as an assistant to you in VR, so that you'd be like a virtual reality player, and then you'd have a little assistant that can float around or maybe do tasks for you. But I'm also open to suggestions and feedback if people have things that they really want to see. I know there was some discussion about imitation learning. I think that's something that we should certainly tackle along the way. If there are other topics that people want to go over, then I'm happy to either do offshoots or also just work that into the main branch if it works in there well. So Thank you all for watching. This has been a huge success. We're above 200 subscribers, which honestly I didn't expect when I started this, so that is great. Again, if you like it, hitting the subscribe button and do all those things that everybody tells you to do anyway, so I don't even know why I mention them. And just thank you for watching, and I look forward to doing more of these videos in the future. Take care.